Okay, so sa katong wala pa nakagets nga lang na OH ni. So, pwede niyo balikan to si osmium tetroxide, no, nga forming an osmate ester. And you will have to redraw para makita ninyo how you will obtain your product there. And you will have to redraw like CH3 here is oriented away from you. So you have another carbon. You have a broken line wedge, which means this is oriented away from you. And this is CH3. This one is hydrogen. And then oriented towards you is your hydrogen, right? So once you have your osmium tetroxide in the presence of pyridine, okay, we copy this. What you will get actually is seen man ng imong addition, right? Okay, seen man ng imong addition, di ba? So what you will get, sorry. You have, I have already names people. Okay, so we'll have our osmium here. On the same side. O, O, osmium, O, O, and then you have your double bond, O, O here. Sorry, there is a double bond. So what happened is, okay, so you have here and having your NHSO4 and water, of course, you will get your this copy lang ta on the same side. And you have your OH. Your OH on the same side. Okay. So it's very simple. And then you can look at the geometry of the both. Stoichiometry rather. Okay. And here, this is just the same as the name. No? So hydrogen is oriented away from you. You have group, 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 and there's another group. Then you can determine on the stoichiochemistry. Okay, and if the osmium adds to the side, the ring aside, you can also add the ring aside. Okay, copy just this one. Pag the ring aside si osmium, no? So what you'll get is, let me see the okay, so you have your carbon here forming a bond with oxygen from osmium. Okay, one, you have your oxygen also. You have your double bond, oxygen. Bigyan sa man to, pag-add. So pareha na katong sa addition dito kang bromine. So one of the double bonds kang double bond diri Wala man gipakita ni Koan ni kasi pangalan ni author ani nga book kung yun sa pag-add. The most probable mechanism is that if you have your kani, it will add here. It will use, since this one is more, it's an electrophilic one, so you have this kani, it will be concerted. No, this is the probable. Pag-attack ano niya diri, you have this one, and what happens is that kani sobraan siya og electrons, gamiton na niya to attack here, like that. So you'll get your osmium. Kita bang arrow? Kita our arrow. So you get an electron here, and you will have kaning manobra si osmium, all the electrons, so you convert it niya to form a bond there. Okay, so you'll get your osmium diri. You have a bond, 5-member diri. So once ma-cleave na siya, what will happen is that you will get your kani. And you will have your ma-cleave ni siya. You'll have your OH. You get your OH, and then you have your OH. So you'll see this one is just same kaning earlier, right? And you'll check on, once you get your chiral centers, you will have to determine on the stoichiometry of each carbon atom. So the two actually, if this is to RR, if this is RR, you have your RR, and the other one is SS. Oops. So the two actually are enantiomers of each other. So from a trans, what you get are enantiomers, a pair of enantiomers. So this one, you can distinguish which one of the two, if they is obtained in racemic mixture. If they can be separated, the two is separated. This one is optically active, and the other one is also optically active. Okay, and you can actually the optical rotation, no, will be, if this is positive, this one will be negative. But of course, if they are present in the same amount, no, in the mixture of the overall, of course, it will become a racemic mixture, and still you don't see a rotation of plane parasite. If one will be like 50%, 50%, you get a racemic mixture. Okay, but if you will separate these two, kung pag at the end of the reaction, for example, kapag-react mo anin at the end of the reaction, this is present in 50-50 amount in racemic mixture, 50% of each, then you don't see an rotation of the plane polarized light. But if you separate your product, okay, for some other organic techniques, for example, a separation with a chiral, with chromatography, no, using a chiral beads, no, and you can do column chromatography, and you can separate this one, and you check with the instrument, optical instrument, no, and you will see that rotation, the plane polarized of each will be different. So if one is positive, for example, 100, the other will be negative. Okay, so that is for the cis. Now, what will happen if you have your Nasaan yung kapihon? So what will happen sa trans? Where's my... Okay. So let's go sa trans. Ang sa hinihitabo sa trans. So don't. Oops. Okay, so you have your sharing. So you have your trans here, your Z. The question is, explain the following facts treating with Z to butene with us, gives optically inactive. It cannot be resolved. But if you have the A to butene, the trans with the same reagent, you have optically inactive but can be resolved into enantiomer. So mato kung giingon nga optically inactive siya kay racemic mixture katong kaganina, no? That you will get Kani, what you will get kaganina, pag this one is present in 50%, no, what you will get actually is your racemic mixture, which is mixture, which is optically inactive. Okay, if you get this one to be like 1, the RR will be like 50%, 50%, and the other one also is 50%. Again, of course, further separation. You'll have separation using chiral reagents in column chromatography, so they can be resolved. The two enantiomers can be resolved. And will be checked with optical instrument. So tawag atong optical instrument. Okay. So again, let's go back to the cis, no? So you will have to redraw again para mabalaan na to kung unsaang. So say na redraw na nato, no? Katong kaganina, you have to form your osmate ester. So you can form your osmate ester diri ang side. So your CH3, CH3, you have to draw that towards you, wedge, dark. So the dark means it's towards you. The broken line, hydrogen is oriented away from you. Okay, so pag mo add si osmium acetate, osmium tetroxide, no, to form an osmate ester, ma-push ni siya down, and you'll have your hydrogen still oriented away from you, CH3 oriented towards you, and all of this, okay? And you have your osmate ester, pag mag-cleave siya, you get your OH here. So this is same. So alternatively, you can add din his osmate ester, or alternately, osmate ester be added rin aside. So pag diri mo add si osmate ester and then cleavage, you'll have this hydrogen oriented away from you, the same hydrogen as H3 oriented towards you, and kanipot sila. No, once it will be cleaved, you have your HOH here. Okay, what will happen is that kani pag tan-aw nimo sa H3 na actually siya plane of symmetry. Kani pod pag tan-aw nimo your CH3, CH3 on the same side, they are of plane symmetry. Hydrogen, the same side, they are of plane. They are mirror image of each other. The right side actually is the mirror image of the left. The right side is the mirror image of the left. But if you would like to check, we can actually check on the configuration of each chiral carbon center. So we can check. So you have your like group 1, you have your OH, group 2, you have this, and then you have your CH3. So on second configuration and ng second carbon, hydrogen is oriented away from you. I will call si Ronel. Kaning carbon to Ronel, what is the configuration? Is it R or is it S? Ronel, so you can count, you have 1. The first priority is, in 1, the first priority is?
OH.
OH, then you have your kaning carbon with OH, and then you have your CH3. So, unsa man na siya? R or S? Counterclockwise or clockwise?
R, ma'am.
Counterclockwise R. Ay, clockwise.
Paana? So, is it R or S? Paana man? Is it clockwise or counterclockwise? Clockwise or counterclockwise? You have 1, 2, 3, 1, 2, 3, 1, 2, 3. Unsa man na? Counterclockwise, clockwise?
Clockwise.
Clockwise. So R
Clockwise,
or S?
ma'am. R.
Okay, you have R. So look at the second carbon, third kung dito mag-start, no, the second katong sa double bond. So let's use green. You have a blue. You have the OH. You have this. And then you have your CH3. Of course, first priority is the OH. Second is kani. Third is kani. Okay, and hydrogen is oriented already away from you. So whatever we get from here is the configuration. So you have 1, 2, 3. Paana? 1, 2, 3. Counterclockwise, clockwise.
Counterclockwise.
Counterclockwise. So what is the configuration? R or S?
S.
Okay, it is an S. So carbon 2 here, if you start counting from here, this is R, this is S. Now let's look at the second product, no? Tanaw na to kung pareha ba siya o configuration. Okay, so you have your naka-blue na ko. Let's look at this first carbon here. You can set double bond. You have your OH, you have your CH3, you have your hydrogen. You have this one. You have 1, 2, 3. So paana? Right? Counterclockwise or clockwise? Counterclockwise. So the configuration is S. Okay, let's look at the second carbon. You have your OH. You have your OH. You have your CH3, and then you have this one. So priority 1, priority 2, priority 3. So you have, no, this is 3. You have 1, 2, 3. So R or S? Counterclockwise, clockwise?
Clockwise.
Clockwise. So this is R or S?
R.
This is R. Okay, so what happens sa kani? Is it the same compound or different actually? Kaning withdraw. Remember the pareha siya, no? Sa H3, no? So pareha siya sa H3, you have 1, 2, 3, 4. Pareha ra siya actually, no? So balik, i-flip mo siya, i-flip mo ni siya nga carbon, you have your R, diri si S diri. Okay, so this is, ano si pangalan ani? 1, 2, 3, 4. You have butane and 2, 3. You have 2, 3 butane diol, right? And if you start counting from here, from this one, you have, or this na lang, 1, 2, you have your RS. 2, 3 butane diol. If kanipot siya, kani siya no? Kung diri ka mag-start, you can also start counting diri nga side. Kaya either way, pareha raman siya. You still get your 2, 3. Kung diri ka mag-start, you still get your 2, 3 diol. So either way. So pareha ra siya if start ka og name from left or right. So in other words, you have start ka diri, 2, 3, and this is RS. So you actually get also RS. Start counting from left here. Because you still get your 2, 3 butane diol gihapon. So either way, so this is the same compound. Even if mura siya lahi, no? This is actually, only get actually 1. This is actually an identical compound, and because you get a plane of symmetry, this is a meso compound. So however you separate this one, however you couldn't separate this, of course, because you only get 1 compound, and this is a meso compound, and it is optically inactive, and it cannot be resolved. You don't see a plane of rotation for this one. Okay, so sa yung indicator, pag R and S, gani inyong makuha nga. So you have to be careful, labi na kung na-asymmetry, because you might actually get a meso compound which is optically inactive. Okay. So let's take a break before we go to the oxidative cleavage of alkenes. Now let's take a break for 30 minutes. And if you have nothing to do, you can read the chemistry of catalytic asymmetric dehydroxylation. So when you say asymmetric dehydroxylation, okay, they actually used, this is a new discovery, and it's a 2001 Nobel Prize in chemistry. Sharpless was the organic chemist who discovered, found a new catalyst, no, to do the hydroxylation aside from osmium tetroxide. So you can read in this. We can take a break. I think you already have the book and the slides. So we'll have 30 minutes break, and after that we'll continue. Is it okay with everyone?
Yes, ma'am.
Okay, so we actually have how many slides left? So you have 8, 16, and then, okay, hapit na. You just need an hour, 30 minutes probably to continue. Okay mo, kaon sa ako kay gutom ko. So I'll see you in 30 minutes and in 30 minutes, okay? And by the way, I can have, wait lang. I can have a breakout room if you like. Assign automatically. Can have a breakout room if you like, no? And you can work on Room 1 ra tanan. 1, 2, 3. Dapat duha ka breakout. Let's see. Okay, and you can do the breakout and you can answer actually problem set number. Or your problem set you can share. Okay, pag ma-end na ni siya, let's i-end lang. You can chat in there, you can discuss with each other, and I'm not listening. No worries.
Oh, 31 days.